Welcome. This is Algebra 2-1, semester final exam review. I am filming this because we seem to have a schedule where we have a break right before finals. So if that's what's occurring for you, then hopefully you can spend your break studying these videos and come to Starbucks with questions regarding those when I meet with you on outside tutoring. If you don't happen to be having a break, then I still suggest studying these videos. This will go through the first packet of just units 1 and 2. That'll be the first episode that we do, and then we'll do units 3 and 4 and 5 and 6. Let's go ahead and open up this packet. Very first page we open to. This is a reference page. That'll probably be used mostly in unit 3. So make sure that you don't lose that. Okay, first problem. Let me zoom in here enough that you can see it. Okay, here we go. Solve the following equation for y. Basically on this kind, guys, I highly suggest that you circle the y's, make them your creepy dudes. And then before we do anything as far as following the inverse order of operations, first we should distribute, get rid of our parentheses. Remember, you know to do that because the number's sitting right next to the parentheses. That keys you into that. So let's go ahead on this step. We'll distribute as well as we're going to use commutative property and get our x's over here together. So we'll go negative 3x plus x plus 2y. That is the commutative property. We've just changed the order to group these together closer. Then we have 5y minus 6x minus 12. Now, our next situation here, we could combine these. Negative 3 and a positive 1 would be a negative 2x plus 2y equals 5y minus 6x minus 12. We just combined our like terms on that step. Okay, next thing that I think I would be inclined to do is probably circle our creepy dudes, what we call creepy dudes, that's our target, and get them to the same side. So let's subtract 5y. I'm only choosing to move it this direction because there's less stuff over here. So now we have subtraction property of equality, cancels the y out over there. Now we have our y's grouped together. Bring down our negative 2x. A negative 5 and a positive 2 would leave us with a negative 3y equals, bring down our other stuff here, negative 6x minus 12. Next step, get this y alone. Go up your PIMDAs. Because now we have one spotlight on our creepy dude, we can just start undressing the problem. So what's being added or subtracted to the creepy dude? It's not the 3, he's sitting right next to him. That means multiply. We go on out, there's a negative 2x. To get rid of the negative 2x, it's a positive 2x. Add to the like term on this side. That cancels. We have a negative 3y equals negative 4x minus 12. We're done with add, subtract. Now we look at this and we see what's being multiplied or divided. Negative 3 is being multiplied, so we do the inverse. We divide. Divide on each side. That will reduce to 1. So we have 1y equals. Distribute here. So we would have a negative 4/3 x over negative 3 plus a negative 12 over negative 3. Now, our negatives can cancel, so that becomes 2 negatives make a positive, so it's positive 4/3 x. Negative 3 goes into negative 12, positive 4 times. So again, on the final, I ask that you show all the work, show all the steps, and then circle the correct answer, but then look at the incorrect answers and point out what's wrong. This one has a 2/3, that's what's wrong. These, well, this one has the wrong y-intercept, and this one's just totally out. It's out to lunch, okay? Going to the next problem. Let's see if I can scoot it up here. Yeah, I have to pull my focus back a little bit. Whoops. You guys run these cameras so much better than I do. Boy, do I respect you for that. Okay, next problem. I suggest when you start one of these to look at the window first, because you've got options here. I'm teaching you how to take a test, not just do the math. So what I would do is I would look, the graph goes that way, and the graph goes with an open circle this way. Closed circle because of the equals underneath the inequality there. Open circle, no equals on it. So we're looking for a line that goes to the left that's open circle. If we look here, that's got that. This does not. We can mark this option out right now without doing any math. This one has it, and this one has it. Now the one question is, are they at -3? 1, 2, 3, yeah, that's at -3. 1, 2, 3, that's at -3. This one's at 0, so that one is out as well. And I would circle right there being the problem, circle right there being the problem. Okay, so now I'm down to 2 options. That's a nice thing to have on a test. When I look at these, I see this one's at -3 going that way, and this one's at 0 going to the right. This one's at -3 going to the left, and at -3 going to the right. So I come up here and look. My limits, neither of these are at 0. So I can mark this one out and circle that. Now, my hope would be that you know how to do piecewise graphs and that you actually could have graphed this. I'm only teaching you how to take a multiple choice test. If you don't remember how to graph a piecewise function, then I suggest that you go back to Unit 1 and you review piecewise functions. This video is going to focus more on taking this test. Okay, next problem. Again, I would look at my windows. So we've got at -2, an open circle. So I know x is less than -2. We've got up here x being greater than +1. And it's got a closed circle, so it's greater than or equal to. So that's the first thing that I go to on these options. This one says greater than without the equals to, so it's out. This one says greater than without the equal to. It's out. This one says greater than with equal to, greater than with equal to. Now let's look at the x is less than -2. X is less than -2, x is less than -2. So I look here. Is there any difference in these? No, there's no difference. So one of these two has to be it. I look in here to see what the difference is in these. The only difference I see is that negative right there and the negative right here. These are negative slopes. So I know that if it's a negative slope, it goes up towards the left. That means that line, that third line over there, is going up towards the left. Well, if I look, it is going up to the left. So that is correct. But let's double check this one. This one says that this first line that has this limit is going up to the left. Does this one go up to the left? No, it's going up to the right. So that's what makes this one wrong. And then we've eliminated to get to that. Okay, next problem. Super key word here. If they underline or bold print a word, it's important. Range. Range is my y. Range is going up and down. Y is going up and down. So it's asking what are the description or the limits on y. Well, I can see that y, going up the y-axis, we come clear up to -2 before we hit an open circle. So we know that -2 is a lower limit with an open circle. Now you could write it like that. Another way you could write it, if you like this way better, is interval notation. Okay, open circle with the parenthesis. Now we keep going up the y-axis and we come to the top of the graph. This is at 1. So we could do 1 with a closed circle, or 1 with an equals to. So we look here. These are completely off. It seems like they're completely unreasonable. But what they are is the x, or the domain. So I would mark these as domain, showing me I totally get what they were doing there. Now we go over to the range where we have y's, and it seems to be the right numbers. And we look at what's the difference here. These are the same, the only difference is right here. So which is it? Is y equal to -2 or not equal to -2? We look up here, it's not equal to it. So we have to go with this choice here. And that shows what's wrong with that choice. Okay, next page. We're already to number 5, good going. First thing that I'd look at here is the shape. What shape is an absolute value? Specifically, a negative absolute value. A negative absolute value should clue you in that it's an upside down V. This is Unit 2. Go see Unit 2 notes if you're having trouble with that. So immediately, we can look at the shapes. That's upside down, that's upside down. This one is not. It's upside down, but it's a U shape. And this one is not upside down, it's a V that's right side up. Now I look at my answer choices. What I notice different here is this is a solid circle, and this is an open circle. That's at -3 with a bracket. This is at -3 with a parenthesis. I go up here to my window, I notice it's got the bracket. So again, without doing any math hardly, I have eliminated all but the right answer. Number 6. If you read this, 3 students were chosen to show their solutions for the solving of the equation y equals a parenthesis x minus h plus k for x. Their work is shown below. Determine which students were correct. When I look at this, they're either saying 2 of the students are correct or all the students are correct. They don't have any options where there's only 1 student correct. So that inclines me to come down to their answers and see which ones are equal. So I look here, y is divided by a, y is divided by a, y is divided by a. They all agree. Negative, negative, negative. They all agree there. K is divided by a. Oh, k is not divided by a here. K is divided by a there. So far, student number 2 is different. You don't have an option of student 2 being the only right one, so we have to assume student 2 did not do it correctly. That marks out D as an option. It also marks out B and A. But just to make sure, I want to go one step further and make sure that student 1 and 3 have everything the same. They have a plus H and a plus H. That tells me C is my best option. Again, guys, use problem solving, critical thinking, as much as you use math on a math test. Okay, in this problem, we're solving a system. Now, I know that I have not given you many that look like this. You've got 3 different variables. You still use the same principle that you used when you were doing 2 variables. Let me show you. We use elimination when we do 2 variables. So let's use elimination. We can have x plus y plus c equals 3. Negative x plus y plus c equals 5. If we happen to add these, do you notice how nice I was to you? The x's wipe out. We would get 2y plus 2z equals 8. Now let's try this again. Let's go with that middle equation and the bottom equation. Negative x plus y plus z equals 5. X plus 2y minus 3z equals 2. Add these two and you can see the x's are going to wipe out again. That works out beautifully. 2y and 1y would make 3y. Please do not say 3y squared. You would only add their exponents if you were multiplying. Negative 3 plus 1 would be a negative 2z equals 7. Now if we look closely, we could add these two together and our z's would wipe out. So let's just do that. 2y plus 2z equals 8. 3y minus 2z equals 7. Add these two together, the z's wipe out, and we get 5y equals 15. And now you can solve for y. Divide by 5, divide by 5, we find that y equals 3. Don't get freaked out when you see a math problem and it looks different from some that you've seen in the past. Use what you know in math and just take it step by step. Now, if you're using a whiteboard during the final and you do this kind of a thing, make sure to transfer the work onto your paper. So we find that y equals 3. Not a lot of showing what's wrong with the incorrect answers because obviously we've got some issues with those. Okay, let me zoom in a little bit more on these. Whoops. Okay, next problem. Which equation is obtained after the translation of the graph up 2 units, left 6 units? So let's go up 2, would be at 0, left 6, 1, 2, 3, 4, 5, 6. Right there is where we're going to be. This is at a left 2 and down 0. We notice that our options here have down 2, that's a k value because it's outside, and an up 2, and those are not options at all. This from the origin is not down 2 or up 2, so that's out. Now we have to remember which way does the left right go. If you don't remember that it's opposite, this would be negative 2, then you could actually plug in a negative 2 in here and find when it would equal 0, because that's where you're at on the y. Negative 2 plus 2 would be 0. There we go. Negative 2 minus 2 would be negative 4. You'd be down here. So it's this one. The negative being what causes that one to be popped out of there. Okay, another graphing problem. This one says, which of the following is the graph of a negative absolute value, x minus 3 halves, minus 5 halves k. Or not k, that's just a k value. Let me zoom out just a little bit. I want you to see something. If we look at our limitations again, like I showed you on the other ones, this would be a solid circle at negative 3, an open circle at positive 3. If we look, all of the graphs have that limitation. So they caught on to the fact that we were looking just at the windows. So at this point, I'd say go to the shape. The shape is a V. This one's not a V, it's out. This one's not a V, it's out. And I would label that quadratic. Just so you're impressing me that you know your vocabulary and that you know why those are out. Now this one is a right side up V, this is an upside down. What we've got here is an upside down. So we need to circle the upside down, cross this one out, put not reflected. That way I know that you know why it's out. Impress people with your vocabulary. Unit 2. Unit 2. It says the graph of x squared, all of these seem to be x squared, is compressed by a factor of 1/2. Remember, compressed or stretched goes in your a value. So if we write this, f of x equals plus or minus a x minus h squared plus k, we can plug in where these values go. It says compressed by a factor of 1/2, so let's put the 1/2 in for a. We've got the x, we've got the squared. Now it says it's right 3 units. To go right, remember the sign's opposite, so it would be a -3. Down 1 unit. So -1. That's our down. Now it's just asking which of the following matches this. So if we go here, they've matched everything except they have a reflection. We do not have a reflection, double check that. And they went the wrong way with the 3, wrong way with the 1. Here again, we have a reflection, and now they've switched those two. Here looks to be our answer, so we'll circle it. But what's different in this one, again, they switched these two. Okay, show me clearly what's wrong with them and what's right with them. Next problem. The next problem is really interesting. They're having you compare features of quadrilaterals. They say compare the two functions represented below, determine which of the statements is true. Okay, same vertex, so we need to know what the vertex is. Well, HK format, the vertex is your H and your K, so it'd be 6, -4. That's the vertex for that one. The vertex is the turning point of the graph, which we see here that it's -2, -4. Okay? So the functions don't have the same vertex. The minimum value of f of x is the same as the minimum value of g of x. Well, we know that our minimum or maximum is our k value. Our k value here is -4. And our k value here is -4. So we do know that that's correct. Now to mark out what's wrong with the others, this one says same axis of symmetry. Well, our axis of symmetry happens to be the x value in our vertex. There's our a of s there, it's 6, and here it's -2. So that one's out. The minimum value of f of x is less than the minimum value of g of x. Well, we already established their minimums are the same, so that one's out. Please make sure to highlight your notes where you're having questions or you're not following. Go back and listen again, study it some more, Google it, search on other sites, and then come see me at Starbucks if you're still struggling with it. Okay, identify each graph as being linear, quadratic, absolute value, or cubic. You should have these memorized, I would hope. This is cubic. By the shape we know, absolute value. Go back to Unit 2 if you don't remember these. And this is quadratic. And all you need to do is find that order of them. So here, They say A is quadratic, that's wrong. They say A is linear, that's wrong. Now they say A is cubic, so we're good. So that marks those two out. Okay, now absolute value. Oh, here they say that B is quadratic. It's not. Absolute value is what it is. Okay? On number 13, let me zoom in just a little bit. In the function x cubed, it's translated, how will the domain and range of the function change? Well, we need to remember that with linear and with cubic, this one goes like this one goes like this. The domain is all real numbers. The range is all real numbers. So no matter what we do translating wise, it's not going to change that it's all real numbers. D is our option. We can't have restrictions on cubic and linear. They go forever, both vertically and horizontally. Okay, next one. Number 14. Which of the following functions has a range of all real numbers? Well, I would go back to what I just said. Linear and cubic have ranges that are all real numbers. With absolute value, it is affected by the k. It's either going to be greater than or less than the k value. Sorry, I went off the screen there. And quadratic, same thing. It's going to be less than or greater than the k value, depending upon whether they're reflected or whether they are standard. If they're in standard value, then they'll be greater than. If they're in reflected, then they'll be less than. So we look here, this one's linear. We know that because the x value is to the first power. This one is absolute value. It's got the bars like this. Absolute value. This one's quadratic. It's raised to the second. And this one is cubic. It's raised to the third. So we know that the range is all real numbers for linear and cubic, so we know it's number 1 and number 4. We look for that option. Okay? Next one, I love this graph. I just love this assignment. I'm pretty sure that you'll see something similar because it's showing you a function that looks extremely overwhelming probably to you, and that is graphed. You don't need to do anything with that. It just says over which intervals is the graph positive. I would highlight the word positive, and then I would come over and I would just bold print whenever this graph is in the positive. So it's positive from -3 to 0. It's positive again from about 2.5 to infinity. Okay? So coming over to the graph, it's showing you where it's positive. That's what they're looking for. So we look for -3, 0. Ooh, right here. It's got that marked. And they've got the 2.5 to infinity mark. So I think we found our graph right there. Down here on the B, it's showing that to -infinity is positive, and we know that that's not right because of that section. On C, it's showing you from -3 clear over to the 2.5, this whole section, but we've got this section that's negative. So we can mark out C and circle just from 0 to 2.5. We could also circle up here to infinity that they're not correct. And on this one, on D, it has again from -3 to 2.5, so it's out. Okay? that is it for Units 1 and 2, studying for the final. Thank you very much.